guys, today I am going to be doing the Lewis structure of acetate. Sorry, not of acetate, of acetic acid, but we know that acetate is C2H3O2, so of acetic acid means there's this acidic hydrogen right here making it an acid, hence this. So here's my H plus. I kind of view these as two different things, although they are going to be mixed when you do that Lewis structure. So we're going to start off by accounting for carbon. Our carbon is our central atom because carbon bonds on all four sides. So here is my carbon. And I know that I have 3 hydrogens, and I know that I can bond right now, technically 4, right? So if you suggest we bond H, it wouldn't make sense, right? Because then I won't be able to bond the other carbon or the 2 oxygens. So I know I'm going to have to bond a carbon and a carbon. The first thing I'm going to do is I'm going to bond these hydrogens. So here's my hydrogen, and here's my other hydrogen, right? And this is sharing a pair of electrons, guys. These two, one's from the hydrogen, one's from the carbon. Here's another one. Here's another one. One from the carbon, one from the hydrogen. Next, I'm going to single bond this, obviously, to another carbon because I have... The reason you're single bonding is basically because you have 1 more hydrogen and 2 oxygens. If you double bond this, you're only going to have room to bond another oxygen unless you go another way, which I'm not going to get into. I'm just going to go into the basic one, but you probably know what I'm talking about if you're watching this video and you had the idea. But now I have 2 oxygens and 1 H plus left. So the way I approach this is I think that I can double bond this carbon to an oxygen, right? So boom. So boom, boom. Here's my double bond. Now it's sharing 2 pairs or 4 electrons, right? And then I single bond the other side of the remaining one side because I have 1 here, 2 here. I can have 1 more bonded right here. I'm going to single bond an oxygen on this side, and then that leaves me with room for 1 more single bond, right? Here's a single bond. For 1 more single bond with hydrogen, and I will bond that right here. And to visualize the electron idea here, you have 1 here, and then you have right here. So you have to think about it like this. In general, when you think about the electrons, there's 2 electrons per hydrogen, right? 1, 2. You can only single bond. The max you can have is a single bond. But with carbon, you can have more than 2 because you have 4 sides to bond on, right? You have 8 electrons surrounding a carbon because there's 4 bonds per carbon. So you have 8 electrons, 2 bonds, and typically it happens to be unshared pairs, but that's not what it is here now. You have a lot of different ways you could draw this structure, but this is the way I draw it, and this is what makes the most sense to me.